Okay, so this is a quick little review of electron configurations because they're going to be really important in this unit as well. If you still can't do electron configurations, you won't be able to explain why periodic trends are the way that they are. So just as a review, the off-ball principle says that we fill from the lowest energy to the highest energy level being 1s. So they're actually written on this chart in order of energy. So you fill this one, then 2s, then 2p, then 3s, and so on and so forth. Each box or each orbital holds 2 electrons. S's have 1 orbital. P's have 3 orbitals, so they could hold 6 electrons. D has 5 orbitals, so they can hold 5 electrons. And F has 7 orbitals, so they can hold 10 electrons. Sorry, I think I said D has 5, it can hold 10. Anyway, so each box holds 2. You just keep tacking on electrons for the more electrons that are in your element. So hydrogen only has 1, so it goes 1s, and then the exponent of 1 tells you how many electrons are in that specific orbital. 1s2 means there's 2 in there. Get down to boron. Once you fill up 1s2, 2s2, the next one is 2p, so you got to put the next one in the p orbital, and so on and so forth. Okay, so you write them like this. Hund's rule we talked about. This is really for diagrams, electron diagrams like this, where you draw the electrons as arrows pointing up and down. Up means it is a spin up, down means it is spin down, or plus 1/2, minus 1/2. That's really what those mean. And so in each box, 1sp up, 1sp down. That's the Pauli exclusion principle. And they have to, if you're in the 2p, for example, you have to spread your electrons out, and they all have to be going the same way before you start pairing them up and putting ones down. So like if I only have 2 to put in here, I would put 1 up here and 1 up here. Okay. There is a word for these orbitals in 2p that are all the same. Like there's 3 orbitals in the 2p. They are called degenerate orbitals because they all have the same energy. Okay, and then you start filling them up. This is the electron configuration. This is the orbital diagram. So make sure you read carefully when I ask you to do one or both or whatever it may be. Writing shorthand configurations. Remember what you want to do is find the noble gas that is before your element that takes up the first few electron or first however many electrons. If it's neon, for example, it takes up the first 10. And then after that, you start at whatever row your element is in. So the next row, the s orbital. So it should be something in brackets, your noble gas in brackets, and then something s2 and so on and so forth until you get the right amount of electrons. So this is 10 krypton, 5s2, 40, 10, 5p2. And then fill the orbitals until, like I said, you have the correct number of electrons. The only one that shouldn't be full is your very last one. This p only has 2, when p holds 6. Everything else before that should have full order. And if you don't remember what order they go in, kind of go by this diagram. If you want to draw it on the exam, you are welcome to do that. We go 1s. This is the s block. S holds 2. This is the p block. P holds 6. This is the D block. D holds 10 because there's 10 columns. And the F block holds 14. The S block starts at 1. The P block starts at 2. The D block starts at 3. And the F block starts at 4. Okay, so then you just kind of go in order of how the periodic table is set up. Okay, if you need help with that, let me know. It is important to point out the difference between core and valence electrons. So your core electrons are all the electrons closest to the nucleus. They don't actually do anything in chemistry. They don't participate in chemical reactions. It's always the ones on the outside that are doing the reactions, and those are called valence. Those are the ones that we care about and are going to be most important in this unit. Okay, so it's the outer electrons. They're the ones that do the chemistry. They are the electrons in the highest energy level, meaning the electrons with the largest N value, energy level of value. So like that first number here, whichever ones are the biggest N value are the ones that are valence electrons. So those are the ones on the outside. Those are the ones that are going to do all your chemistry. Okay, there were some exceptions I wanted you to know based on electron configurations. That's the chromium column and the copper column, because remember half-filled shells, like if I've got 5 all up electrons in a d orbital, is kind of stable. Completely full is even more stable. So sometimes an electron will go from an S to a D in order to make it a little bit more stable. And that only happens for the chromium column and the copper column. We did these ones as practice in the last section. So if you want to do them again, that's great. But now I'm going to use these to talk about the periodic table and how it works. Now, the first thing I want you to do is watch the crash course video, and then I will go into the notes.